Mark Sargent sent me something. It was on Lake Ontario, I think, or no, it was on Lake Erie. It was on.
Was it frozen?
No, it wasn't during frozen season.
Mm.
But there's a mill. You could just do a YouTube search for the shrinking mill, and I think it's in Ontario. But on is Ontario butt up to Lake Erie? I'd have to go look. I think it's on Lake Erie. Anyway, the shrinking mill. You just do a search. I posted some things on it on my Facebook page right after Mark Sargent sent it to me. But anyway, there's this area where if you're driving towards on land, driving towards this area of water where there's a mill there, it's like in a bay area or something. But you can see that mill from the road, but it looks really big in front of you. But the closer you get to it, the smaller it gets. It shrinks, which is the exact opposite of everything else that we see. Stuff further away is smaller until you get closer to it, and it gets bigger. But this thing gets smaller. Now, some people are trying to say it's an optical illusion. I don't think so. I mean, it is an optical illusion, but I don't think it's an optical illusion the way they're saying it. In other words, people will say that the moon looks huge on the horizon, but if you actually take a picture of it and take a ruler to it, and then take the ruler and measure the moon when it's straight up in the sky, it's the same, width across. And they'll say the reason that it just looks bigger is because when it's up in the sky, we don't have anything to compare it to. When it's on the ground, it looks so big compared to, buildings or trees or mountains or whatever may be there. I do think that there are also cases where it is magnified due to the atmosphere. But they were trying to say the same reason why the moon can be the same size high in the sky and when it's on the horizon, but look bigger on the horizon than it does in the sky. They were trying to say that the same thing with the mill. But I've watched that video so many times and I'm not seeing that. I'm seeing this thing get smaller and smaller, like it's really magnified and it's raised up. In other words, when you get closer to it, it starts to drop, on your eye line as well as shrink. You know what I'm saying?
That's strange.
When you're further away, it shouldn't be raised up the way it is. If they're just trying to say it's, because they're trying to say the way the trees in the distance kind of create like a frame, the roads on the ground and the trees around it form like a archway. And so they're trying to say, well, it's just an optical illusion for that. No, this thing's being magnified. And I believe it's being magnified for the same reason that all the tests that we did on Lake Michigan showed that the Chicago skyline's being magnified, because we have all these billions and billions of microscopic dots called moisture in the atmosphere that cause, according to the experts, people who believe in the globe, they say the atmosphere really is acting like a lens. What type of lens? They put a magnifying glass in front of the camera.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
the atmosphere really is acting like a lens.
yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. So it magnifies. But that was a pretty interesting video if you haven't had a chance to see it. The shrinking mill.
Yeah, no, I haven't, but I'll definitely check it out tomorrow.
But that explains why, and I've shown in multiple tests, why you can have buildings or ships at a distance going away from you due to atmospheric refraction and magnification. It will cause the lower part to disappear. And the problem guys like Danny and others have that want to say, no, it's the curvature that's making it disappear, is nothing ever leans backwards.
Right.
The optics are completely wrong. Whenever you're looking at something at a distance, if you presume you're on a ball and that the ball is obscuring the lower part of the ship or the lower part of the building, then there should be some perception of leaning away. But it's never that way. It's always straight up and down, which is
straight up and down. Absolutely.
Completely off visually.
Right. Yeah, because if it's curved, then it should be on that rotundity.
Yeah.
And leaning away from where we are.
None of the buildings, none of the ships, nothing does that.
Right.
So Is all this under mirage and then looming is under mirage, or what are the semantics of looming versus mirage?
Okay, well, that's all. I guess that's all in the details of the terminology. From what I understand, technically, I think mirage has to have an inverted image, whereas there are other atmospheric effects such as looming or towering that are purely displacement, and you don't necessarily have to have an inverted image in order for refractive effects to occur in the atmosphere.
So they would all fall under the category of atmospheric refraction.
I guess that would be a good thing to say. Yes.
Okay, so again, this is their graphic. According to them, we know the Earth's a ball, so therefore this is the way it's working. Chicago's over here on the left. We got the curve of the Earth here, and the light rays, which would normally be going straight across, have to be bent due to the atmospheric lensing, the density of the atmosphere and whatnot, causing the light to refract downward, basically just conveniently enough over the top of the bulge of the curve so that we can see it on the other side. Now, here's where I would differ with this whole idea. Again, just sort of flipping the board. Let's just say we don't start with any preconceived notions of the Earth as a globe. Let's entertain for a moment the completely absurd notion that water is flat and it always seeks its own level. And we're looking across a flat plane of water, 46 miles across. Check this image out right here. Now, I caught this image shortly after Rick and I returned from our trip across the lake. We grabbed a bite to eat, and then we went out to the beach, and it was still clear out, so we got the camera out and looked 46 miles across the lake to see this right here. This image is extraordinary. Okay, the boat right here, I'm going to guess, is less than a mile away. And I base that because these people walking in front of the camera here are walking across some rocks that sort of jut out and kind of fence in the harbor area. And they are only about a quarter of a mile away from where we were when I shot this. I shot this image from right about here. This is where we were looking across, and this is the area right here where those people were walking. And the boat, as you could tell by the size of the people on the boat, wasn't too much further beyond that. So maybe a half mile to a mile, or at the most, I would say, away from where we were. All right, now when I was headed back to Chicago to catch my flight, I snapped this picture of the Willis Tower. And this is, if you go on Google Earth, this is right about the area right here where I believe I was when I took that picture. Looking across, it's only about 0.6 of a mile. So I'm just a little over a half mile away, and look at the size of the tower as compared to the car that was diagonally in front of me. We were looking at the Willis Tower from this direction right here when we were on the other side of the lake. Now, okay, so let me slide the car over and shrink it down to the appropriate scale beside the boat. Do you see something rather interesting here? This building is significantly magnified. The image on the left shows the size and scale of the building next to a car at 0.6 of a mile away. The image on the right shows the same building and the same car with a boat at 46 miles away. The atmosphere really is acting like a lens. What type of lens? A convex lens or a magnifying glass. So I'm going to suggest this is what's happening. The atmosphere is acting like a lens, which magnifies the city, brings it up a little closer, and as it does so, we start to lose a little bit of the bottom of the buildings, and perhaps due to the density in the atmosphere, there's additional refraction that takes place that makes it drop down even more. Is that what happened? Let's look at it from another angle here, from the side view. I'll bring our graphic back in of refraction. Let's go ahead and orient the graphic so it better represents what we're looking at here. I'll angle the light rays to show the density of the air here causing the refraction, and bring our lens in so we can magnify the city. It brings the city up, and as it does so, we start to lose a little bit of the bottom of the city, and perhaps either due to the magnification or due to additional refraction, maybe it is dropped down a little bit more, and this is what we end up with. Huh. Just like we saw. Now this is a still frame from the half-hour video that I did, and the numbers you see there are all based on the numbers that Tony was giving me based on his device. His device said it was 37 nautical miles, which is 42.6 statute miles, but when you plot the same exact location that we were at, the exact distance you get on Google Earth is 46 miles. So you basically add about 4 miles to all the numbers that you saw in the half-hour video. But here's where it gets interesting, at least to me. Both of these pictures were taken with the same camera. Now, if you remember from the half-hour Chicago skyline video, I was saying I can see Chicago. We're about 42 miles away. I can see it. The problem is trying to get the camera's having trouble focusing on it because it's moving up and down and it's so zoomed in. But I can totally see it. Rick was not zoomed all the way in. He was using my camera, the Nikon Coolpix P900, but he was only zoomed in about halfway when he grabbed the shot above. Now I know that when I got the image below, I was zoomed all the way in. And so some people may point to one of my videos where I was actually debunking myself. If you remember that NASA video showing the Earth and the Moon, and the moon was going in front of the Earth. So I did a little experiment where I used a baseball as a moon and a larger ball as the Earth. And I got at the end of a long hallway with my Canon 70D and zoom lens, and zoomed all the way in on it. And this was the image that I captured doing this experiment. There's the NASA image on top, and there's my image. And so, you know, just by virtue of the lens, it does magnify the distant object to make it look proportionately large to the object that is closer to you. So is that what's happening here? Well, both of these images were shot from the harbor area here. The red line at the top is where we were in the boat. We're just about to depart when I asked Tony to stop, and I got the camera out to shoot Chicago. And the lower red line is where we were on the beach when I took the picture on the bottom there. So, and the distance between those two locations is less than a quarter of a mile. So it's negligible. We're still looking about 46 miles across either way. Now, here's the shot from the beach before I zoomed in. Now I'm zooming in, and I'm going to stop it right about here. That's about halfway on the zoom, and I believe that's where Rick had the camera set when he took the picture above. Based on the size of the building right here, I'm going to guess that he was about halfway. Alright, so let's go ahead and continue the zoom. And this is zoomed all the way in. The Nikon Coolpix P900 has an 83 power optical zoom, and that little punch in after that was the digital zoom afterward. It has a digital zoom that goes beyond the 83 power. I did not go all the way in with that. I just punched it a little bit because I wanted to frame it with the ship right there. So that's 83 power plus. So gonna guess it's probably the equivalent of about maybe 90 power zoom or so right here. Now let's bring the picture in from the halfway zoom, and I'm going to go ahead and bring our car back in and slide the picture in from Chicago, and I'm going to scale the car to the appropriate size to the boat right here and go ahead and slide the car over to the building. So this is what the car and the building look like at half zoom. So let's try something else here. I'm going to unfreeze the video and back it off so it goes backwards, and we're zooming out back to the shoreline, and now I'm gonna bring it forward again, and let's see, right about here is where we have some fairly decent resolution where you can still make out the building. I'm going to zoom in here with the computer. This is a computer zoom now on this still image, And I'm going to bring the other image in from the half zoom and scale the car over to the digitally zoomed in image of the almost completely zoomed out shot. And so you got 3 different zooms here. One almost completely zoomed out, one zoomed about halfway on an 83 power optical zoom lens, and the one on the right, of course, all the way zoomed in with a little touch of digital zoom on top of that in the camera. And when looking at these images compared to the one on the left, which is just shot with my iPhone, I got to tell you, it looks like it's being magnified to me. Especially when you consider the fact that that building is like 45 miles away from that boat. It's 45 miles away. So, looks like there's some serious magnification going on here. And, some of that could be due to the lens, I'll give you that. But I also know what I could see with my own eyes. Now, I understand you may not want to take my word for it, so all I can say is go up there and do it yourself. But based on what I saw with my own eyes, as well as what the quote-unquote experts had to say regarding how the atmosphere can act like a magnifying glass, I'm still going to go with it as being magnified. Again, you can go out there and test it for yourself. But remember, let's just go back and hear from the experts once again about what they say is happening.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
And the fact that you can see things further than the supposed, formula for measuring out curvature. I mean,
well, yeah, I mean, you especially with the infrared photography, people doing infrared.
No doubt.
And lasers shooting across really far distances, line of sight lasers painting targets 100 miles away, impossible on a ball. Microwave technology that's also line of sight, beaming across the Mediterranean Sea. Again, there's so many world records that they don't even realize. They're doing these world records, but they don't realize while they're doing it that it disproves the ball.
Right, absolutely, without a doubt.